This episode is brought to you by Meta for Work. It's not just sci-fi anymore. Virtual and mixed reality are transforming how business works. Architects can use mixed reality to walk through buildings that aren't even built yet. People from around the world can meet up in more immersive ways, working shoulder to shoulder in virtual spaces to get real work done. And all sorts of professionals are getting hands-on training in safer, more cost-effective virtual environments. Meta for Work. Work smarter, closer, safer, together. Visit forwork.meta.com to learn more.
Reebok has officially partnered with college basketball champion and fashion superstar, Angel Reese. A style-forward athlete, Angel Reese has her uniform on the court, but also off the court. That includes the Club C Vintage, Reebok hoodies with Dream Blend fabric, and classic leather, just to name a few. Simply put, she's got an eye for style. Shop Angel's first curated collection, Angel's Picks, including a limited edition Reebok Angel Reese t-shirt at Reebok.com.
This is SpaceTime Series 25, Episode 27, for broadcast on the 4th of March 2022. Coming up on SpaceTime, Perseverance celebrates its first year on the red planet Mars, how lightning actually starts, and discovery of the largest radio galaxy ever seen. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Mars Perseverance rover has celebrated its first year on the surface of the red planet. Since landing in Jezero crater back on February the 18th, 2021, the car-sized six-wheeled mobile laboratory has knocked up an impressive list of firsts in its search for ancient microbial life on Mars. The mission successfully deployed the Ingenuity helicopter, a tiny tissue box-sized twin-rotor aircraft which has been scouting ahead of Perseverance, looking for interesting geological formations and determining the best way to get there. The 1,025-kilogram rover's also begun collecting samples of Martian rock and regolith as part of what's the first ever sample return mission to the red planet. It's collected 6 rock core samples so far for eventual return to Earth, and will collect 2 more in the coming weeks from the Cha'ai Rock Formation, named after the Navajo term for frog. These are a set of dark rubbly rocks, representative of what's seen across much of the crater floor. Perseverance has also tested MOXIE, the Mars Oxygen In Situ Resources Utilization Experiment. It's the first prototype oxygen generator on the red planet. Perseverance recently broke the record for the most distance travelled by a Mars rover in a single day, travelling almost 320 metres on February the 14th, its 351st Martian day or so of the mission. And it performed that entire drive using AutoNav, the self-driving software that allows Perseverance to find its own way around rocks and other obstacles. The rover has now nearly wrapped up its first science program in Jezero crater. The location was selected because it contains some of the oldest rocks on Mars, and an ancient lake bed with the remains of a fan-shaped river delta that once flowed into the lake, bringing with it lots of sediment from further upstream. These rocks and sediments would have preserved and recorded the entire history of the local environment going back billions of years, an environment that once hosted liquid water and so is a prime location in the ongoing search for signs of ancient microbial life. But the mission hasn't been without its challenges. The rover's first attempt at drilling a rock core sample came up empty, prompting an extensive testing campaign to better understand the characteristics of fragile rocks. The team also needed to clear out pebbles that had dropped into part of the sampling system that holds the drill bits. Meanwhile, Perseverance's airborne companion Ingenuity has also proven itself to be invaluable. Although it's been grounded for the last month or so due to a major dust storm, it's now resumed flying and has just completed its 19th mission. It was originally designed to only fly 5 times to simply prove that an aircraft could fly on another world. Perseverance and Ingenuity are now making their way back to their original landing spot, from where they'll then head towards the river delta as their search for evidence of past life on Mars continues. This report from NASA TV.
Propulsion, go. EDL phase lead, go. We have deemed Perseverance ready to execute entry, descent, and landing on her own. Confirmation of entry interface. Perseverance is currently going 5.3 kilometers per second, about 120 kilometers from the surface of Mars. It will start controlling its path to the landing target. Parachute has deployed, and we are seeing significant deceleration. The heat shield has been separated. Perseverance now has radar lock on the ground. The back shell has separated. Skyfin maneuver has started, about 20 meters off the surface.
Tango Delta, nominal.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life.
We have Dr. Mohan here with me. Of course, you know her from the landing coverage.
Hey, Doc, how are you?
I'm doing very well, Mr. President. Perseverance is my first mission at JPL, where I've gotten to work from the very beginning of formulation all the way through operations. Being able to work with this incredibly diverse, talented team that has become like a family, spending years creating our own technological marvel has been a privilege.
You did an incredible job.
It's our honor to be given these kind of tasks. It's what we live for. And so I'm surrounded by a few hundred of my best friends in this and a couple of other control rooms and online. You know, these are really big team efforts, and it's important to us to get as much of the team to join with us today as we could. And we really appreciate your time.
Appreciate it. I'm flattered you take the time to let me talk to you.
This is SpaceTime. Still to come, how lightning actually starts, and discovery of the largest radio galaxy ever seen. All that and more still to come on SpaceTime. A new study has confirmed the hypothesis that lightning is actually triggered inside thunderstorm clouds by streams of electrons through the condensation of atmospheric water vapor molecules. The findings, reported in the journal Geophysical Research Letters, could fundamentally shift the future of lightning research and ultimately help protect humans and infrastructure from lightning strikes. Lightning, for all its breathtaking and fearsome beauty, remains an incredibly mysterious force in nature. Now researchers at the University of New Hampshire have discovered a key piece of evidence which has eluded scientists ever since the days of Benjamin Franklin's kite experiment, namely how lightning actually begins in a storm cloud. It turns out the clue was contained in data collected in 2018 by a large array of radio telescopes in the Netherlands known as the Low Frequency Array, or LOFAR. These observations allowed scientists to actually see lightning initiation in 3 dimensions on the subatomic scale for the very first time. And this offered an increase in timing precision and accuracy over previous studies, allowing scientists to image lightning in far more detail. After months of piecing together a 3-dimensional map using radio waves, the authors grew increasingly confident that the sources of lightning are indeed streamers, that is, a branching development of tiny spark-like discharges. Their finding supports the hydrometeor initiation theory, the idea that lightning is formed on a subatomic level by the condensation of atmospheric water vapor inside rain clouds. Previous research using small radio sensor arrays helped scientists study the electrical breakdown at the start of large lightning events, which generate strong radio signals. But the more powerful LOFAR radio telescopes allowed scientists to obtain details of lightning initiation starting with weak radio events. The 2 major ideas on how lightning began involve either cosmic rays from outer space enhancing the electrical field within clouds, or through subatomic processes that cause electrons within the cloud to form streamers, in other words, filaments of cold plasma. The problem is, it's difficult to actually see inside a storm cloud to find out which theory holds weight. Cameras flown into clouds haven't proven very successful, and so scientists turn to radio telescopes for this research. Of course, the lightning coming out the bottom of a thunderstorm cloud isn't all there is. There are also jets, elves, and sprites, which flash up in brilliant colours above thunderstorm clouds, but are rarely seen from the ground. Apart from occasional reports of strange light seen above thunderstorms by airline pilots, almost nothing was known about these strange events until scientists studying thunderstorms began picking them up in photographs. Jets, which can reach heights of 80 kilometres, may be the tallest lightning on Earth. Sprites are transient vertical column-like plasma structures flashing high into the Earth's atmosphere, often in reddish clusters at altitudes of 50 to 90 kilometres. They're thought to be large-scale electrical discharges triggered by a rare positive lightning that originates in the anvil ahead of a thunderstorm cloud where positive charges tend to accumulate. Positive lightning is about 5 times as powerful and hot as the regular type of lightning normally seen, which is technically known as negative lightning. Positive lightning also lasts about 10 times longer, allowing it to strike many kilometres away from a storm. In fact, this is what led to the famous expression, a bolt out of the blue. Unlike negative lightning, which occurs either inside a thunderstorm cloud or from the base of the cloud to the ground, positive lightning travels outside the cloud, striking the ground directly. Sprites are sometimes preceded by yellow halo emissions, lighting up a millisecond before the sprite, about 70 kilometres above the initiating lightning strike. Sprite halos look like 50-kilometre wide disks, and are thought to be produced by a weaker version of the same ionization process which produces the sprites. Elves are flattened expanding reddish glows of plasma, some 400 kilometres wide but lasting just a millisecond, which have been seen at altitudes of 100 kilometres above thunderstorms. They're thought to be caused by the excitation of nitrogen molecules due to collisions between electrons, energized by lightning from the underlying thunderstorm. Another close relative of sprites are known as blue jets. They're very bright, narrow cones of plasma seen above thunderstorm clouds at elevations of 40 to 50 kilometres. Their colours believed to be caused by blue and near ultraviolet emissions from neutral and ionized molecular nitrogen. Blue jets are also thought to be associated with strong hail activity during thunderstorms. Another closely related phenomena, known as blue starters, are thought to be shorter, brighter versions of blue jets, only reaching 20 kilometres in height. And then there are spectacular features called gigantic jets, which are thought to be bigger versions of blue jets, stretching for kilometres in length. Which all goes to show that it really is a different world above the clouds. This is SpaceTime. Still to come, discovery of the largest radio galaxy ever seen, and later in the science report, a new study shows that dogs really do grieve for the loss of a friend. All that and more still to come on SpaceTime. Astronomers have discovered the largest radio galaxy ever seen, a massive stellar city at least 16 million light-years across. The findings, reported in the journal Astronomy and Astrophysics and on the pre-press physics website archive.org, indicate the galaxy, which is some 3 billion light-years away, is 100 times larger than our own galaxy, the Milky Way. Radio galaxies have actively feeding supermassive black holes that are very luminous at radio wavelengths, hence the name. The study's authors say the pair of plasma plumes ejected from this black hole's accretion disk is the largest structure ever made by a galaxy so far known. Supermassive black holes are thought to look at the centers of most, if not all, galaxies. As matter falls onto a black hole's accretion disk, it's ripped apart at the subatomic level, releasing huge amounts of energy. Now, most of this material will eventually pass beyond a point in space called an event horizon, a sort of point of no return, beyond which matter falls forever into the singularity of the black hole, unable to escape. However, not all of it falls into the black hole. Some is directed into powerful jets before reaching the event horizon, and this material is then shot out into space perpendicular to the accretion disk at close to the speed of light. Depending on the angle we see them at, these are referred to as quasars, blazars, or active galactic nuclei. And these events are hypothesized to slow down the birth of new stars by blowing material out of the galaxy and into intergalactic space, and by heating up surrounding gas, preventing it from cooling enough to collapse into star-forming molecular clouds. Therefore, these active black holes strongly influence the life cycle of the galaxy as a whole. These new observations were captured by the European Low-Frequency Array Radio Telescope LOFAR, which we mentioned in our last story. They show the two plasma plumes reaching out into deep space from above and below the accretion disk. It's simply the biggest structure ever seen generated by a single galaxy. The study's authors have named this giant structure Alcyoneus, after the son of Uranus, the Greek mythological god of the sky. This giant is said to have fought against Heracles and other Olympians for supremacy over the cosmos. The massive plumes of this black hole are so large, astronomers think they could be used to reveal information about the mostly elusive strands of the cosmic web, the network of filaments and nodes, which are composed of galaxies, galaxy clusters, and superclusters that make up the large-scale structure of the universe. While the galaxies and galaxy clusters in the filaments and nodes are clearly visible, detecting the medium between galaxies has only been successful in clusters. And that's where this new radio galaxy comes in. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study warns that COVID-19 infection could significantly increase your risk of heart disease for at least a year after your recovery, even if the infection didn't result in hospitalization. The findings, reported in the journal Nature Medicine, are based on an analysis of a large healthcare data set from the United States. The data shows that people who contracted COVID were significantly more likely to suffer from dysrhythmia, ischemic and non-ischemic heart disease, peritonitis, myocarditis, heart failure, and thromboembolic disease than people who avoided infection. Almost 6 million people have now been killed by the COVID-19 coronavirus since it first escaped from Wuhan, China. However, the World Health Organization says the true death toll is likely to be double that amount, with some 450 million confirmed cases so far globally. Scientists have engineered bacteria to convert industrial pollution, including greenhouse gases like carbon dioxide, into useful chemicals such as acetone and isopropanol. A report in the journal Nature Biotechnology claims the process is already being used in the food industry to make yogurt and beer. But researchers have now shown that this bacteria can be genetically engineered to create chemicals it doesn't normally produce. The processes that manufacture these chemicals usually emit greenhouse gases, but this new method fixes more carbon than it emits. And so the authors believe it's a carbon-negative alternative to current processes. Paleontologists have uncovered fossils from a new species of spinosaurid dinosaur in Portugal. The 129-million-year-old fish-eating predator named Iberspinus natarioi featured a crocodile-like skull and a spiny sail on its back. A report in the journal PLOS ONE suggested this early Cretaceous period theropod was about 8 meters long and probably waded in water, waiting to ambush fish and other aquatic prey with its crocodile-like jaws. A new study has found that, just like people, dogs will grieve the loss of a close friend. The findings, published in the journal Scientific Reports, showed some 86% of dog owners had witnessed negative changes in a surviving dog once a companion dog passed away. They reported symptoms like increased attention-seeking, less willingness to play, less activity, more time spent sleeping, being more fearful, eating less, and whining or barking more often in the surviving dog. And these changes lasted between 2 and 6 months for most dogs, and even longer for a quarter of all dogs. The authors suggest that these negative behavioral and emotional responses could be due to both a grief-like reaction in response to the loss of their friend and a reaction to the grief of their owners. Now, go hug your dog. A popular article in a Christian magazine has put forward the proposition that religious miracles can be real because they don't violate the laws of nature. The problem is, rather than provide any evidence capable of duplication through scientific method to support the claim, the article instead focuses on attacking a 1748 essay by the philosopher David Hume, which looked at the probability of an event being a miracle. It then cites a number of scientists who believed in the existence of a god or intelligent designer. In the end, the article fails to prove its claim, namely that miracles can be real and don't violate the laws of nature, instead relying on opinions and faith rather than any real scientific facts. Tim Mendham from Australian Skeptics says it's an old argument.
There's an interesting article actually put up on one of the Christian sites that basically says that a lot of the scientific objections to miracles, saying that they violate the laws of nature, are not based on science, but actually more on philosophy. This is actually a bit of a straw man argument that's being put forward by this particular article, saying that one of the major proponents of this claim that miracles violate the laws of nature was David Hume, who was a philosopher in the early 1700s. They call him not a scientist, which is true actually, because the whole concept of scientist is a more recent concept of someone who systematically investigates phenomena, etc. And even the word scientist wasn't invented until the mid-1800s. So almost calling that David Hume is the main case maker for this anti-miracle claim, so he's saying it's anti-science, is a bit false. It's creating a straw man to then say that he doesn't represent what science is about. So the article then goes on to talk about violating the laws of nature, and of course what it comes down to, basically, apart from quoting a lot of old, quote, scientists, close quote, from several hundred years ago, including Isaac Newton, who also believes in astrology, so I don't think that would go down well with the religious people, is that God can actually work outside the laws of nature. So the breaking the laws of nature doesn't apply to what God does. It's an old argument to say that how can this happen? How can God sort of make things happen that are not part and parcel of everyday life or as the laws that we know it? And naturally, like a lot of things, they will drag in all sorts of quantum physics type arguments and that sort of stuff to try and explain how things might work. So you just get these arguments going on about religion versus science, even though most religious people say science works with religion. By and large, it's a problem area. And this particular article, whose argument starts off with David Hume was a philosopher, yes, although in those days that's what all scientists were called, they're sort of natural philosophers and that sort of thing.
Yeah, that's
right. Natural philosophy was what we would now call science. So using a term like philosophy
is misleading. PhD, isn't it?
That's right, the Doctor of Philosophy, yes. Yeah.
They're providing a lot of quotes from people, but they're not actually providing any evidence.
No, the only evidence is that these people were either philosophers.
These people think this, yeah.
Or that early people working in the sciences or natural philosophy were sort of believed in God. Well, that doesn't make a lot of sense because, most people did. And certainly back in the 1500s and 1600s, that was a pretty common belief. And therefore, they tried to manipulate what they saw into a God-oriented world. And that was where you get problems. And suddenly people said, maybe we just drop the God bit. But this is saying, no, miracles do happen and because God can work outside the laws, so therefore the laws don't count. Therefore, anyone who criticises miracles on the basis of laws is heading down the wrong track. So it's a false argument starting from a premise that, yes, God exists.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.